All right, solving equations multi-step. You can obviously see that from the first screen. It's check it, check it, check it, check it. So it kind of scaled it back a little bit to where the difficulty is not going to be so much, but you're going to be working on verifying your answers. One of the things that I want to make very clear is that if you're struggling with a problem, please put a star next to it. Don't stress about it and just move on and then send that over to me whenever you're done and saying, this is the one I had a problem with, this is the one I had a problem with, this is the one I had a problem with. Then I can address it and we can go over it together. This was one problem in particular that I was told that you struggled on and was very frustrating for you. I'm going to just break it down with like terms, a positive 2x, a positive 4x. Whenever you put those together, since you're combining like terms, they give you a 6x. I'm going to rewrite the problem. Then we still go back to the top. Do you still see like terms? Yes. I see a -2 and a -8. Combining like terms, combining means add. So I'm going to be adding a -2 and a -8, getting a -10. Now it's just down to a simple two-step equation. There's no distributive, but we do have add and subtract. Okay. Rewrote it. Is there multiply and divide? Yes. So divide by 6. X equals 6 times 6 is 36. That leaves 4 left over. So 6 and 4/6 or 6 and 2/3. Simplify that. We're not going to go through and check it on this one because I don't want you to struggle anymore with that problem. We'll just say peace out to that one. For each of these problems, I want you to hit pause. I want you to solve the entire thing, and then I want you to substitute the answer back in and check it. And if you don't feel comfortable checking it yet, and you want to, like, I don't really quite understand what you mean by check it, the format in which I'm doing it is exactly what I'm going to be looking for. So whenever I'm checking your work, if it's not done this way, I'm going to say you need to review that before we can move on. So a one-step equation, you should have already solved it because you hit pause. X equals 24. So whenever I'm saying check it, the last step, you're saying it's 24. That's nice. So instead of putting X, you said X is 24. I'm going to rewrite it. 24 minus 5 equals 19. This is where we start following PEMDAS. There's only one thing you can simplify, and that's the 24 minus 5. 19 equals 19. This is you knowing for sure that you're turning your work in and your answer is correct. That's the benefit of math versus other things. A two-step equation. Again, pause, solve, check. Okay, so you should have solved it. There is adding and subtracting, so we're going to start there. We're adding 10, so we're going to subtract 10. X divided by 4 equals 30. You rewrote it. Is there multiplying or dividing? Yes. So I'm going to multiply by 4. X equals 120. Did you check it? What does that look like? You're saying that X equals 120. Okay, so let's rewrite the problem. 10 plus 120 divided by 4 equals 40. We don't have a variable in this problem anymore, so we can solve it using PEMDAS in the correct way. Parentheses, exponents, multiplication, division, addition, subtraction. There's no parentheses and there's no exponents. That means that we have to start with multiplication or division. And that would be right here. 120 divided by 4 is 30. Simplify the rest of what's on the left side, which would be addition or subtraction. So 10 plus 30 is 40. 40 equals 40. This side by side of you solving a problem algebraically and then checking it algebraically is proof. Like you're doing proofs. You are proving that the work that you did is algebraically correct. I want to keep on throwing in distributive and like terms because I feel like they're important. Distributive can lead to like terms, and I think that those things, whenever they start occurring in problems, I just don't want it to be the first time you're seeing it. So I'd like for you to pause the video and work out all these distributive and all these like terms. If for some reason you're struggling with one of them, please do not emphasize it or anything or get upset or feel anxious about it. Just put a star next to it and add it to the list of things that I need to ask a question about. That simple. All right, so distributive. You should have multiplied x plus 9 by 2. So that's 2x plus 18. You should have multiplied 3x minus 8 by 4. So that's 4 times 3x is 12x. 4 times negative 8 is negative 32. Multiply 3x minus 2y times 3. 3 times 3x is 9x, and then 3 times negative 2y is negative 6y. So far, we don't have any like terms after we've done the distributive property. So now we're doing 2x plus 3y times 9. That's going to give you 18x plus 27y. No like terms in any of these that we use distributive for. That doesn't mean it can't happen. It just means that so far we haven't run into it. I want you to go ahead and take a look at the like term side. 2 and 2, they're just plain numbers. You know 2 plus 2 is 4. You've been doing like terms way longer than you thought. There's a number followed by the same variable, a number followed by the same variable. You have 2 x's and 3 x's, you can put it together and get 5 x's. A number followed by a variable, is it the same on the other side? A number followed by the same variable, check. All right, so that means we have like terms. 20 minus 50 is negative 30x. Went ahead and threw in some exponents because it just means, do you see a number followed by the same thing? So this could be an 18x squared plus 8x squared, as long as it's a number followed by the same variable arrangement. Take a look at if you have 8x squareds and then you add 8 more x squareds to them, you're going to have 16x squares. This last one is a little tricky, and I remember sitting in math class and having this explained to me. Let's say that we have x times y, and x is 2 and y is 3. 2 times 3 is 6. Now let's say that we have y times x, and that's 3 times 2. Still equals 6. So whenever we're multiplying two numbers, it doesn't really matter the order that they're put in. You know, like a times b times c is going to equal the same thing as b times c times a. So these are still considered like terms. They are a number followed by the same letters. So 8xy's and you're taking away 7yx's is the same thing as saying 8xy minus 7xy, which would give you 1xy. If you want to put a 1 there, that's cool. If you want to put a star next to that one and we can go over more examples like that, that's perfectly fine. Nothing to stress about. I just wanted to throw it in there, introduce it to you. Going through multi-step equations, we're going to go through several of them and then the format to check it. I wanted the whole idea about what we're doing is showing the work for every single step and then plugging it back into the original equation and checking it, making sure your answer is correct. We do not have distributive. We do not have any like terms. We don't have variables on both sides, but we do have adding and subtracting. So you should have paused it already and you should have an answer and you should have already checked it. And you're like, I already know what you're going to say because I've already checked it. And I'm like, that's the whole point. Minus 4 minus 4, 3x equals 16. Okay. I rewrote it. Doing multiplication or division. Yes. I'm multiplying by 3, so I'm going to divide by 3. 16, so 3, 6, 9, 12. So it's going to go in 5, and then we're going to have 1/3. So whenever you were going over rational numbers and you were wondering, why do I have to do this? It's so separate. I haven't found any way to practically apply it yet. Whenever you check this one, you're going to have to understand how to multiply a whole number times a rational number. And so that's where that piece comes in. You can see how that's kind of all tying in together now. Everything you've done through elementary and middle school is kind of culminating into this algebraic form. Uh, to substitute it back in, you'd be doing 3 times 5 and 1/3 plus 4 equals 20. That's the thing you should have had set up for when you checked it. Now you're sitting there going like, oh my gosh, I don't remember how to multiply a whole number times a mixed number. Well, there's two ways to do this. Check it out. Look, you got 3 times 5, right? That's 15. And then you have 3 times 1/3. And you're like, whoa, this looks like the distributive property, because that's how the distributive property works. And that's how it works whenever you don't have a variable in it. What's 3 times 1/3? 1/3, 2/3, 3/3. 3/3 equals 1. So we have a total of 16. 3 times 5 and 1/3 is 16. I will break that down more after we verify that this is correct. 6 plus 4 is 20. Proof that we're correct. All right, now what the heck with the 3 times the 5 and 1/3? So 5 and 1/3 is a mixed number. That means you got a big number next to a fraction. Whenever we were multiplying fractions and we came across stuff like that, it was turn every mixed number into an improper fraction. So that means 5 and 1/3. This is 5 sets of 3/3. So whenever we were adding fractions, we kept the denominator and we added the numerator. 3, 6, 9, 12, 15. So far we've got 15/3. And then you bring this 1/3 down, plus 1/3 equals 16/3. Okay? So if we have 16/3, that is the same exact thing as 5 times 3 is 15 plus 1. We just converted 5 and 1/3 into 16/3. It's improper form. So now that we have that, we can do 3 times 16/3. And yes, you did do this before. What happens underneath every whole number? It's always divided by 1. That way it can maintain its value. Whenever we multiply fractions, it's across the top, across the bottom. 3 times 16 is 48. 1 times 3 is 3. Take a guess at what 48 divided by 3 is. 16. So you can see how the distributive property could assist you in making it to where you don't have to do all of this, and you can just go through and use a practical approach of not having to write everything down. All right. So we don't see any distributive, but in between distributive and like terms, we do see that there are variables on both sides. So I just want you to keep that in mind. Go for it. Make sure you check it. All right. So whenever we have identified distributive and then we also identified that there is going to be variables on both sides, we always start with the smallest variable. -4 is smaller than +10 plus 4x. That gives us 28 equals 14x. Now we're down to a one-step equation. No problem. Divide by 14. X equals 2. And if you put 2 equals x, it's the same thing. Just know that for formal purposes, algebraically, a variable will always come first and then your equal sign. All right, so we didn't have any like terms. We did the add and subtract. We rewrote it, and then we did the multiply and divide. And we ended up with 2. Now we need to check it. -4 times 2 plus 28 equals 10 times 2. Just keep in mind that whenever you're sending the work over, that this is exactly what I'm going to be doing on a sheet of paper. And then if it doesn't look the same, I'm going to point out what is different and what needs to change. So we're going through order of operations, simplifying things from parentheses to exponents, multiplication, division to addition, subtraction. No parentheses, well, at least there's nothing to do inside of them. There are no exponents, but we can simplify multiplication first. So -8 plus 28 equals 20. Okay. -8 plus 28 is 20. 20 equals 20. That is your proof. There's no arguing that. And that's exactly where I want to be. I want it to be, there is no argument about the work that you've done. You know it's right. Anybody that looks at it can say, this is how we did it, and this is how it's done. So again, we can see variables on both sides. Keep that in mind. That's going to hit you right there. All right, you should have gone through it. You should have solved it. You should have checked it. We don't have any distributive, but we do have variables on both sides. Variables on both sides means that we're going to identify the variable with the least value. Negative 2 is smaller than positive 3, so we're going to get rid of the negative 2. And this really works with the dynamics of balancing an equation and what you can do to both sides and what happens when everything disappears. If you have 2x's and you add, if you have negative 2x's and you add 2x's, you end up with 0x's. That's why we have 0 on that side. 5x minus 5. Now look, you just have a two-step equation. There are no like terms, but there is add, subtract, plus 5. I rewrote it. Is there multiply and divide? Yes. Divide by 5. X equals 1. You're just sitting there going, x equals 1. Cool. Did you prove it? Let's check. 3 times 1 minus 5 equals negative 2 times 1. Okay, so parentheses, there's nothing to do inside of them. Are there any exponents? No. Is there multiplication or division? Yes. We will do both of those at once. Why not? 3 times 1 is 3 minus 5 equals negative 2 times 1 is negative 2. 3 minus 5. Negative 2 equals negative 2. Check. If anybody tries to argue, you don't have to say anything because you can just point at your paper. And if they're going, you're wrong, you don't have to argue. Just point at your paper. All right, I'm just going to keep on pointing out that we've got variables on both sides. All right, I'm not trying to trick you on anything, but I do want you to pause. I want you to go through, solve the problem. I want you to substitute back in and check it. All right, you should have gone through all that. No distributive, but there are variables on both sides, so we need to start with the smallest variable. Negative 5b is smaller than 6b, so I'm going to get rid of that and move it. Regular two-step equation. There are no more like terms. You can see that with the 6b and the 5b, we did add up like terms. So I mean, it is still happening. It just doesn't look the same as it always does. They're stacked on top of each other in the format we're using. Is there adding and subtracting? We're doing plus 1. Minus 1. Divide by 11. 4 over 11. All right, now you're sitting there going, how am I supposed to check that? That's a great question. This is a difficult problem to check, okay? So whenever it comes to stuff like this, 4/11ths, I want you to not worry about it, but I want you to at least substitute it back into the problem, okay? So look, here's what I'm talking about, at least doing. If that's as far as you can get with checking a problem, cool. And that means we need to work on multiplying with rational numbers. I want you to understand the concept of when you have an answer that you're able to put it back into the problem. A lot of students will struggle with, if I have the answer 4/11ths, I can't put it in for B. Yeah, you can. This is what it looks like. And then we can work on it from there. Again, we have variables on both sides. Solve it and then check it. Smallest variable is negative 5a, so plus 5a. So that's 9a minus 10 equals 8 plus 10. Divide by 9, a equals 2. Check it. 4 times 2 minus 10 equals negative 5 times 2 plus 8. All right, parentheses, nothing to do inside. Exponents, none. Multiplication, yes. 8 minus 10 equals negative 10 plus 8. 8 minus 10 is negative 2. Negative 10 plus 8 is negative 2. Check. No arguing. Done. Challenge number 1 is the only challenge problem I'm going to give you. I'm not going to work it out on here. I want to see it on a sheet of paper. All right? No worries, no stress, nothing to worry about. Do the best you can. Let's see what you got.